we have a wire, a current carrying wire that is bent to form this shape. So it's carrying current along this wire. I've bent it such that it is forming a quarter of a circle. And it has a radius r. So the current is traveling as such. And we're going to figure out the magnetic field that exists at this point right here, which would be the center of that quarter circle. Now, I'll ask the question I've asked before. Class, is this a math class? No. This is a physics class. Yes, we end up using a lot of math. The truth of the matter is that the physics is the same to figure out the magnetic field at any point relative to this shape. But the math is exceptionally complicated with the exception of that specific point. So we're not going to figure out the magnetic field at any point relative to this other than that specific point. Because really, this isn't a math class, it's a physics class. So, here we go. We need to start with Biot-Savart's law. The magnetic field is equal to mu naught times A divided by 4 pi times the integral of ds cross unit vector r divided by r squared. We need to look at this in terms of 3 different wires. 1, 2, 3. When we look at it, we need to identify ds, right? ds is just going to be a little piece of each of these wires. Let's just look at first ds cross r. Oops, unit vector r. ds cross unit vector r for wire 1. That is equal to ds unit vector r times a sine of theta. For wire 1, theta is equal to. Now, notice ds is here. R, unit vector r, would go from here pointing towards point B. So unit vector r is going to be in the same direction. So for wire 1, what is theta, class? 0 degrees. Therefore, what is the magnetic field due to wire 1? 0. Because if ds cross r is equal to 0, magnetic field 1 is equal to 0. What about the theta for wire 3? What is the angle for the theta for wire 3? Class? 180 degrees. Sine of 180 degrees? Good. So, wires 1 and 3 cause no magnetic field at point P. So the only wire that we really need to worry about to figure out the magnetic field is the wire 2. So again, let's look at ds cross r for wire 2. Well, ds, again, we have r as just unit vector. And what is then the angle between ds and r for wire 2, Tyler? 90 degrees. R, again, is pointed toward point P, and by definition, that's going to be 90-degree angles because ds is tangent to the circle and r is on the radius. So that is going to be 90 degrees. So that's the sine of 90 degrees. So for wire 2, ds cross unit vector r is actually just equal to ds. Okay, let's see. So we come back to magnetic field for wire 2 is equal to mu naught I over 2 pi, or sorry, 4 pi, over 4 pi times the integral. Now, instead of having ds cross r, we just have ds over r squared.
Could you take r squared?
Why?
Constant.
Because it's a constant. Notice for this circle, r doesn't change, and I'm going to change it to big R. So mu naught times I divided by 4 pi times big R squared integral of ds. Well, that is just going to be the arc length. The integral of ds is just the arc length of this, so I'm just going to replace that with s for now. Mu naught I times s divided by 4 pi big R squared. Unfortunately, my s and my r are getting close to one another. I'll try. R. There. That looks good. All right, we know s is equal to r times theta, so we can replace s with r times theta divided by 4 pi big R squared. Big R cancels out, and we have mu naught times I times theta divided by 4 pi r. And remember, when you use this equation, theta is in radians. So we have a specific equation here for any part of a circle, as long as we define theta in terms of radians. For this specific example, we had theta was equal to 1/4 of a circle, or pi over 2 radians. So for this specific example, the magnetic field 2 is equal to mu naught times I times pi over 2, all divided by 4 pi times r, or pi cancels out and we get mu naught I divided by 8r. Or we could just take a circle. If we have a circle, then theta would be equal to 2 pi, and the magnetic field would be equal to mu naught times I times 2 pi divided by 4 pi times the radius. Pi would cancel out, and we would get mu naught I over 2r. So on and so forth. We could take 4 circles. We could just, do x number of loops. It doesn't really matter.